Training Department at Collabra Tech. On behalf of Collabra, I will welcome all of you to this special seminar on big data. Let me briefly describe and introduce Collabra Tech to you, and then our subject matter expert, Mr. Sandeep Agrawal, will deliver the seminar on this most demanded technology. Collabra is a $550 million US-based IT staffing firm, and TECT is the training arm of Collabra. TECT stands for Technology Academy for Competency Training. Through our 40 offices in more than 10 countries, we have been offering more than 50 state-of-the-art training programs, and more than 350 plus corporates are our clients. Most of our vendors and clients rate us in top 3 training providers, and we've been offering training programs on more than 10 emerging technologies. For example, IoT, big data, cloud computing, machine learning, AI, and many more. Our state-of-the-art training programs have bagged many awards, especially in big data and IoT. We have been ranked as #1 training provider last year, and we have retained this position in this year too. Collabra Tech has been nominated as the top 5 training institutes on big data technology. To know more about our training programs and to get help on any stage of your career, you can contact us on these given numbers or can email us at jointech@collabra.com. In addition to this, you can also join our Facebook and LinkedIn groups to stay in touch with us. With this, I'll hand over this presentation to Mr. Sandeep Agrawal. Happy learning and good luck.
Hi guys, good evening to all of you, and welcome all of you once again on the Collabra webinar session. And I would be a host tonight for this 1-hour seminar on big data. So I believe just want to have a quick check if all of you can hear me loud and clear. If you can just confirm on the chat window if I'm audible to all of you. Thank you, Narendra. Thank you, Raj, Pramoda. Thanks a lot. Thank you, Sunil. So let us start the session. Let us not waste any more time. So today's session is on big data, understanding the technology and what are the different applications which can be used to process big data. To begin with, let us understand what big data is all about. You must have read a lot of articles, blogs, and news about big data, like what exactly big data is all about. Let us clear the myth. Big data is not only the data sets which are large enough, it could be termed as different types of data, complex data, and even sometimes the data which is generated at a very high speed. So if you see the diagram below on the left hand side, it talks about three V's, that is the volume, velocity, and the variety. So in the industry, big data is termed as a large or a complex data set which cannot be processed by any traditional systems or any traditional database mechanism. For example, uh, a big data is also a relative term. It could be that 1 terabyte of data could not be big enough for you to process the data, but even 500 GB of data could be a big data for me, because that much amount of data is not easily processable by my systems. So when I say easily processable, it means that whatever data we have on hand, we need to process the data within the stipulated required time. I cannot keep on just process my data and wait for the results to come out. The data which is required to be processed, it has to be processed in a stipulated time. For example, if I have a 1 terabyte of data, and if it takes normally approximately an hour or 45 minutes to process on a single node, on a single data server, and if my systems or my mechanism or my requirement is such that I need to process that data maybe in minutes, so that data can be termed as big data for me. So I would need a mechanism by which I can process this 1 terabyte of data in minutes. So that is a requirement upon it varies. The requirement varies user to user, organization to organization. So here, when we talk about three V's, we are talking about the volume. Any data which is large in quantum can be described as big data. Sometimes the data may not be large enough, but sometimes the data at which it is generated, the speed at which data comes to you, it may be very high velocity or high speed data being generated at you. For example, data coming from different stock exchanges, markets, where you have a lot of live data coming at the within the trading period. So that data has to be captured and analysis have to be done on that data at real time. So whenever we need to do some real time processing, that basically depends upon you need to match up the capacity of the process, the data generation with your processing capacity. So even that data can be termed as big data. And the third V stands for variety, where your data being sourced from various different uh, databases or different sources. For example, data which is structured data, normally they come from data warehouses or OLTP database servers. You have unstructured data. Now, unstructured data, the source of unstructured data could be your social media platform like Twitter, Facebook, Google. These are all platforms which generate a lot of unstructured data. They not only produce unstructured data, but they also produce a lot of different types of data. And this is what leads to complexity of the data. Whenever we are dealing such with high level of complexity of data, which cannot be processed by a single traditional mechanism, all these three different types of data can be termed as big data. Now, how much data is getting generated in our today's world? We need to understand that, because nowadays we are living in a data-driven world. Wherever we look around, we are basically we are surrounded by data. For example, if you see in a minute, almost 4 lakh tweets are being basically are generated by the Twitter, and then we have approximately 600 plus videos are being uploaded on the YouTube, and if you see about there are 7 lakhs or 700,000 Facebook updates happening in a minute. So if you see all around us, we are living in a data-driven world. Now, only two things can be done about this data. Either we discard the data or we make a proper use of this data. Now, this much amount of data is next to impossible to be processed by a single server or the traditional system what we are having till now, or whatever we will be working up till now. So we need a mechanism by which I can process whatever data we have in our hand, so that all data can be processed and maximum mileage or the maximum benefit can be gained out of such data sets. Now, as we see that these are the different mechanisms from where the data is being generated today, whether you call social media or you call scientific instruments, mobile devices, these are all different sources where the data is getting generated. Out of the total data what we are having today, more than 80% of the data is unstructured, and the life cycle of this unstructured data is very short. The reason behind is that what we are sharing data across different platforms, it will lose to hold any relevance 6 months down the line. Suppose if I want to store whatever data is generated today in the social media and try to process the data after 6 months, it will not be having any relevance after 6 months down. Maybe very few percentage of relevance or relevant it would be after 6 months down the line. So one needs to capture the data as early as possible and then process the data to get the proper insight of the data. So whenever we process some data, we get some insight, and that insight should lead to some actionable insight or some gains to the company. So any data which is taken from the raw form will get processed, will have to be processed, and some actionable insight has to be drawn, and that actionable insight should lead to some profitability, or you can say gain or benefits to the company. That is the basic idea of data analytics. Now, how does big data analytics come into the picture? Because the data is so complex and large, one cannot process this data by the given standards what we are having today. So we need a mechanism by which I can process the complexity of the data and the large volume of data within the shortest time. Now, if I talk about a Hadoop cluster, because Hadoop is basically the processing mechanism or the framework which processes this data and gets the results in very quick time. Now, if I give you a simple analogy, how we can process the data. Suppose if I, in a project, it's a 100 man days project given to a team of 5 people. If I give a 100 man days project to a 5 people team member or a member team, it would take approximately 22 days to finish the project. But if the company wants the project to be finished in a much lesser time, what is the option left with the company? They have to increase the resources. So by increasing the resources to another maybe 10 to 15, they can reduce the production time, or they can reduce the time taken to complete the project. Same analysis is being used in big data analytics. By increasing the number of servers in a cluster, normally up till now what are we doing? We are using a single server mechanism by which we are using all the data is sent to the server and processed by the server. At the most, we can divide the data into multiple servers and get the process done by individual respective. But that will not suffice the requirement, what requirement we are facing today. So we need a mechanism by which I can automatically divide my data in a cluster and allow the data to be processed parallelly. For example, if I have a 100 records table with me, or 1,000 record table, I take a small example of 1,000 record table, and I run a command select count star from table name. So if I run this command, it will give me 1,000 as an answer. But if I divide this query would be executed on a single node wherever the data is recorded. Now the 1,000 records, if I divide across eight machines, each machine having about 125 records, then certainly every machine would be processed by its own processor, and every machine would be run by a single query. So you are running 8 separate queries on 8 separate machines at the same time, and each answer you get as 125 because there are 125 records on each server. And finally, on a different node, you will combine all the values from the output and you will get the answer. So this is the mechanism by which you can process the data much faster and quicker by using parallel processing. Now, who introduced all these mechanisms like distributed storage and distributed processing or parallel processing? It was started by Google in early 2000, they introduced this mechanism so they could easily process the data on their search engine. Remember, they, after all, Google is what a web crawler company. They just crawl all the pages and they bring all the data on their in their table. And if they are not able to process data in very quick time, they will, the people who are browsing or they are having a search on their site, they will lose the interest. So it became a compulsion for them to introduce or devise such technology whereby they could process this data in a shortest time. So Google search engine is the biggest example of a distributed storage and a processing framework. And the mechanism of storage they devised, they call it GFS or Google File System, and the processing layer they called it MapReduce. So they could divide the data on different nodes on different servers, and which allowed them to process the data and get the data much faster and quicker. Now you can see that on Google search engine you can get all the results within a fraction of a second. That is the biggest example of a distributed storage and mechanism. A real-time web application which is using a NoSQL table or a database on a big data platform is Amazon. Amazon today is dealing with, you can say, billions and billions of products in their database. If I were to store that data on an RDBMS table and run a query on the user's request, certainly I would not be able to load the page before 5 minutes. But now on Amazon, we can see that we are able to see the products immediately as the user clicks the button. So these are all different examples of how tables and how the technology is changing over a period of time. We are living in a very fast driven where the data has to be processed in much quicker time. I cannot wait my data to be processed and take its own sweet time. Otherwise, there will be delay in business decisions, there will be delay in all the other work which are depending upon the results of the data. That is why we need to have certain frameworks or certain mechanism by which I can process my data in a much quicker and faster way. Now, to assist us to process this data, we have this technology called Hadoop. Now, Hadoop is basically a device for handling such distributed storage and processing mechanism. As I told you, it was inspired by Google, and later on it was taken up by Mr. Dow Cutting. He is the owner of Apache Software Foundation, under whose the Hadoop has the license. They are the owner of the Hadoop services. And Hadoop is basically, the important part of Hadoop is that it is scalable. You can add more nodes at any point of time without disturbing the existing mechanism. So today you are having a cluster of 100 machines on a Hadoop cluster, and each machine has a storage capacity of 10 terabytes. That means 100 into 10, you can store up to 1 petabyte of data very easily. 10 terabytes into 100 become 1000 terabytes, almost equal to 1 petabyte. So 100 machines of data, when put together in a single cluster, can store 1 petabyte of data very easily. If your data tomorrow increases 2 petabytes, all you have to do, you have to add 100 more nodes in the cluster. So you need not to spend the entire money at the beginning of the cluster. You can grow and you can add more nodes to your cluster as your data or as your business grows. So that is an important part of the scalability. Second, the data is distributed and you are processing the data wherever the data is lying. So you will never bring the data to the processing mechanism. On the contrary, we are sending the code to the data. So this feature is called data locality, where we are sending the process to the data. Automatic failover. Since we are dealing with lot of distributed storage mechanism, and the data is distributed across clusters, so there is bound to you are bound to lose the nodes at runtime. How do you handle the failures of nodes? Because after all, these are all commodity machines, all connected in a network. So you are bound to lose certain nodes at runtime. To have a fault tolerance, normally we replicate these distributed blocks and store across the nodes, so that whenever a certain block is not accessible, you can read the data or process the data using the replica of that particular block. So if I talk in a nutshell, Hadoop is what? Hadoop is basically distributed storage of data in HDFS and processing the data using MapReduce. So we are going to use the storage in a distributed way and process the data in a distributed way. And when I talk about HDFS, HDFS is basically the distributed file system designed to run on commodity hardware. This is the storage arm of Hadoop, which stores the data because I cannot keep my data outside of the Hadoop domain and process my data. I need to bring my data into Hadoop or HDFS file system. HDFS is a flat file system which can store any type of data. There is no boundary, there is no limitation that it can only store a certain section of data. It can store any type of data, you name the data. Could be an RDBMS, could be your unstructured, semi-structured audio files, video files. All you have to just upload the data and the data would be easily stored on HDFS. How do you process the data? There are different layers of processing, and you could use either MapReduce, you could go for Spark, Storm. So there are various process engines available. If you are using MapReduce, again in MapReduce there are various segments of MapReduce. You can write the code in Java, you can use Pig, or you can use Hive. Hive is basically more a SQL structured query. So you can run a structured query, a select statement on unstructured data in HDFS. So if you go and understand the depth of each analyzing tools. So there are various tools available by which you can process the data, both batch wise, or you can say, and both real time. So a batch processing is basically a processing where you are running a process on a saved or archived data. A real time processing is a processing where the data is being fetched at real time and you are generating or you are trying to process the data at near real time, whenever the data gets generated. So we can process both types of data in the Hadoop systems. And there are various components of HDFS. I'm not going to dive deep into those components. Basically, you divide your data and you process your data. Let me explain you how we can give you some live examples now, how we can store the data and how we can process the data. Normally, to run Hadoop, we require a Linux mechanism. We cannot run Hadoop on a Windows system, but you can create a VM, a virtual machine on top of your Windows. So now if you see, this is my VM which is running on top of my Windows, and I'll just show you the Hadoop user interface by which you can access your file system on Hadoop systems. And we can create certain folders on HDFS, and we can upload certain files. So when we upload certain files, we can see that the data would be distributed into blocks. So this is the name node or a Hadoop master node interface where you can access the file system or Hadoop file system. And normally it's a virtual file system, unlike your Linux file system, which is a real file system. You can't go and create a file in HDFS. At the most, you can transfer a file. So let us create one folder under the root of HDFS, and the command would be, so let us create one folder and then let us upload one file, and we'll see how the file looks like. So we say Hadoop fs -mkdir / I would say webinar. So webinar already exists, so we'll say webinar 1. Okay, so we'll verify the folder which is being created on our. So let us type webinar 1. Now the folder is created on our HDFS or the Hadoop ecosystem or the Hadoop file system, and let us upload one file under this folder. So I'll be uploading a very huge file around 186 MB. Now the important part to understand here that every file which gets uploaded, it is not stored as a single unit. We are not storing the file as a single unit. On the contrary, we would be dividing the data into multiple chunks. So we'll see that how the data is being divided into multiple chunks. Now this is a file Hadoop. The command is Hadoop fs -put, and you can give a file name called Hadoop -2.6.0. This file is almost like 186 MB file. It's a huge file, and the destination would be webinar 1. So whenever we upload a file on a cluster, these chunks are not stored on one node. In fact, they are divided and scattered across multiple data nodes or data servers. So we are dealing with large number of data servers in a cluster. Each of the block or the chunk which we are creating by dividing the data, each of these chunks will be stored separately. But currently I'm having a single node cluster. So we could see that we have this file 186 MB file being uploaded on Hadoop file system, and my block size is 36 MB. That means in my case I'm creating a chunk of 36. So it will get divided into multiples of 36 MB. Now if I click on the file system, I could see the 6 blocks being created. So every block would be having 36 MB except the last block, which would be the balance size of the file. So from 0 to 4, all the 5 blocks will be of 36 MB. But the last block would be of the balance size, which is the whatever balance you have. So 36 into 5 becomes 180, and the last block would be around of 6 MB. So in this way, you'll be having 6 blocks being created. Now in a multi-node environment, all these 6 blocks would be not stored on a single node. On the contrary, it would be stored separately on different nodes in a cluster. And now you would be writing or running a MapReduce program where you would be running a process on each of these blocks separately and parallelly. So let us upload a real data set first. That data set is size about 39 MB. So I'll upload one more file which talks about a financial data from a stock exchange. So I'll say Hadoop fs -put nysc .csv to /webinar1. This file is also a very huge file. It's around 39 MB, and this would get uploaded under my webinar folder. So here you can see the file size 39 MB. Now for this file, it will have 2 blocks. One block will be of 36 MB, and the balance block would be of the 3 MB size. Now let me show you how these blocks are divided. So there are 2 blocks being created. Now I will take you to the location where the blocks are stored. So we can see the actual division of data, how the data getting divided. This is the location where your blocks are stored in your system. So I am taking you to that location where the blocks are stored, and we can see the physical blocks. So the latest sub-dir is 1 to 1. So I'll move to sub-dir 1 to 1. Now these are the different blocks which are being stored in my system. And if I access the last block ID for NYSE, so there are 2 blocks. You can see the last block ID is 889 and 890. So there are 2 blocks being created. So now let us access these 2 blocks. So there is 889 and 890. So I can read the data also block wise. So let us do a gedit command. If I say gedit and this block number, that is blk 89. So these are different records in my file, and I'll explain the data. But let us see the last line, last record. It will be broken down into, just the file is opening up. It takes some time to. So in the meantime, I'll explain you the data set. It has 9 columns basically. The first column represents the exchange name, that is NYSE, New York Stock Exchange. Then we have the stock symbol, that is AEA in this case. Then we have the date. So this is the date on which the stock was traded. Then we have the opening price of the stock. So the stock opened at $4.42. And then we have the intraday high of the stock, that is $4.42 was the intraday high. Then we have the intraday low, that is $4.21 was the lowest price of that stock on that day. And then we have the closing price. So we have $4.24 being shown as a closing price. And the number of stocks traded, that is approximately 200,000 stocks were traded on this for AEA on this day. And then we have the last column, which is more like a adjustment closing price, which is very similar to your closing price. If I show you the last record, so the last record would be broken down into, I will be having only 2 columns. So this is what we call the data gets divided. If you could see the last record, there are only 2 columns being recorded in this block. So this last record, or this particular record, got broken up into 2 different blocks. Now let us open up the next block also. So let me close this, otherwise let me close this and open up the 890 block. So you could see there it is. You see the balance, almost like 6 columns. So 3 columns were in the first block, and the balance 6 columns of this record are available in this block. So the data gets physically divided, and in spite of the data gets physically divided, you are able to process the data as a single unit. That is the power of MapReduce. So though the data gets divided, and these blocks are not stored on one machine, please understand that point very clearly. These are stored on a different servers, totally governed by their own IP address. And in spite of having data being recorded or stored on different servers, we are able to process all the data as if it was as a single file. And that is the power of MapReduce. So we'll run a small query on this data, a Java code, and try to figure out certain, we need to analyze something from this data and understand how the data is processed. For that, I'll be running some small Java code for you. So let me open up my Eclipse here. And before that, let me show you the now so just a moment. So this is the structure of my data set: exchange name, stock symbol, stock date, stock price open, highest price, lowest price, closing price, volume, and adjustment close price. I will not take a very complex example here. I will take a very simple example. The idea behind this is to explain you the process, not the complexity of the code, so that all of you can understand how the data is processed. I'll take a very, very simple example here. For example, I need to find total stock volume for each stock. It's a very simple example here. If I were to write a code in a SQL statement, it would have been very easy. I would say select stock symbol and the sum of stock volume and from the table, so, and group by stock symbol, and I would get my result very easily. But if I were to process this data using a Java code and see how the data is basically processed internally by the MapReduce in a distributed mechanism, so that we need to understand here. Hence, I'm taking a very simple example so that all of you can correlate and understand the depth of the process, not to get lost in the complexity of the code. Now, whenever we need to process data in a distributed mechanism, remember that data would be not stored on a single node, it would be divided across multiple nodes. So we would be sending some sort of a MapReduce program. Now, MapReduce, there are two parts. Mapper is basically, its job is to filter the data to the lowest logical level. And reducer job is to run an aggregate function on the mapper output. Or you can say aggregate the values of the mapper. Now, to run a mapper, I need to know what data I need to filter the data, because filtration can be done both column wise and row wise. Out of these 9 columns, I may not require all the 9 columns, so I need to identify those columns which are required to run the query, or which would help me to get the answer for this query in a way. So I don't require all the 9 columns. So why should I extract all the data from the table and unnecessarily burden myself? So here I could see that I need 2 columns. I need stock symbol and volume from my data. So on the contrary, I would make my key as stock symbol. Normally in MapReduce, you deliver or you process the data in the form of key value pair. That thing you need to take care of. So your value will become stock volume. Now let me pick up some data here that all of you can easily correlate with it. Now let me take 4 records from here and put it here. Now imagine these 2 records are in block 1 on some different node, and this is a second block, right? So there are 2 blocks of data, and I would be running a mapper on each of these blocks, because a mapper would be sent to each of these blocks wherever. If your data is divided into 100 blocks, a mapper would be sent to each of the 100 blocks. In short, 100 mappers would be running in your system at any point of time. So this is what we call parallel processing. Now we are extracting the stock symbol and the value. So there are the mapper 1 will produce what? Mapper 1 will produce the key and the value pair in the form of stock symbol and volume, and that would be AEA, 205500, and second record will produce AEA, 194300. Similarly, mapper 2, which was running on second block, will also produce same thing, AEA, 233800, and AEA, 182100. So the first thing is running mappers on each of the distributed data blocks, and they would fetch your key value pair. This key value pair you have to decide, because this key value pair will keep on changing depending upon the requirement of the use case. So now, once you are able to process all the blocks, now this data has to be aggregated, because this is independent data coming from each block. So the data accumulation takes place, and that process is called sort and shuffle process. Now this data would come to a single node where the data accumulation happens, because now we need to aggregate the values by running a reducer. But we need to provide data to the reducer so that reducer can calculate. So this framework, this mechanism is handled by the framework. As a developer, you will not be writing the code for sort and shuffle. You will be writing the code only for mapper and the reducer. So now for each key, all the values will be shuffled into this basket. So we'll get all the values here for each key. So all the values will come here from all the mappers. So you could see that data is coming from all the mappers and so on. Similarly, we'll be having one more key, and maybe ABC, and again they would be having some values here, some values, and so on. So like this, we'll be having all the stock symbols and all their respective values in the reducer phase. Now this data becomes input to the reducer. Now what reducer will do, it will simply aggregate all the values. So in this case, they'll be using the plus operator, and they'll be adding up all the values. So all the values for AEA will be added to you, and finally you get some number. Some big number you will get in the form of, so you get the total stock volume from all the records, and this becomes the output to your file. So in this way, you will get the report from the file as a final output as a file on the HDFS. Now let us run this code and see the process, how the things are processed using a Java code. And anybody who's not good at Java, don't worry, there are various ways to write the code. Java is just one of the ways of handling the MapReduce code. If you are not good at Java, if you're good at SQL or a scripting language, you can certainly use those languages. So don't worry that if you are not good at Java, then how will you be able to handle the coding part, or how you will be able to handle the analyzing part. Now see in the mapper part, what I'm doing, if you can understand the code, people who are good at Java, they will be able to pick it up the code much faster. Normally we are dealing in writables. Writables are in Java are the Hadoop variables. So we deal in writables. So we are supplying the data, or giving the data as input to each map function. So we write a map function which will create the key value pairs, will emit the values for us. So I'm not going deep into the technology or the coding part. I'm just giving you an idea about how the data is read. So data would be read by this value part. So the entire data comes in the value variable. You're reading the data, you're dividing the data using comma as a separator, putting into an array variable, str, and then you are selecting the proper key value pair. So the 8th column was the volume, which was long type. You could declare that data type as long, and we are emitting out by using context.write. Now context is the class to write the data on the Hadoop file system. So basically what I'm doing, I'm emitting out the 2nd column, str1, and the 8th column in my, or in a way I'm emitting out the stock symbol and the volume. So this would be a mapper part, and in the reducer, what I'm doing, I'm just adding up all the values for our iterable values. So I'll be adding up all the values for each key. So you could see that for the entire list of values, I'm just adding up, okay, all my values are added up. And finally, the sum variable, which is a local Java variable, I'm passing the value to a result variable to the Hadoop and emitting out the value, the key and the result. So the key would be the stock symbol and the result would be the total after adding up all the values in the array list. This array list I'm talking about. This is the array list which contains all the volumes coming from all the mappers. So I would add all the volumes in the reducer phase and finally I'll be emitting out the key value there. So now let us run this code and show you what is the result coming out from this data. So you have to create a jar file because there are so many classes, almost 3 classes. We have a driver class, we have the map class, and we have the reducer class. So I need to create a jar file out of all the 3 classes here. And I can give a class name, jar name here, NYSE. Okay. And now let us run the code here. So the command would be, please understand the data set have to be on HDFS. So we already loaded the data on HDFS. So I would say Hadoop jar, and the jar name was nysc.jar. And we have the class name, right? So class name was stock volume. Basically, you have to give the main class name. Now we need to specify the input file. Input file was on HDFS under webinar1 /nysc.csv file, and as an output directory we have to specify a new folder because Hadoop never overwrites the data. So you are always, whenever you are storing the output file, even the output file name is being given by the framework. We are only supposed to give a new folder name. So let us give a new folder name under webinar1. So NYSC output we can say. So this folder will get created and the data would be stored under this folder. So now let us run the job. So now this job will be fired to Hadoop ecosystem, and let us wait for the result. So first mappers would be running here because there are 2 blocks basically. It get divided into 2. I have 2 blocks. So now you can see that the total number of records in the file was 735,000 records were there approximately. So map produced 735 key value pairs. It produced almost same number of key value pairs here, 735 output files. And now see the output here. It is giving you 203 records in the output file. So from 7 lakh records, you have come down to 203 records in the reducer phase. Now, if I want to see the output here, I can go back to my browser. And now you can see that a new folder has been created by the framework, which is NYSC output. And if I click here, you can see the file name, which is part R00. So this file name is given by the framework, and the output file is almost 2.85 KB. I can click on this file and click on download here, and then I can see the output. Save the file, run the process, open the file. So you could see that total volumes of key stock listed out here. And the keys are sorted always because we are passing the data through sort and shuffle. So the keys would be sorted in alphabetically way, and we have the volumes for each stock. So this was a very simple example I shared with you. Many more complex programs can be written easily in Java or many other code. The basic idea was to make you understand the MapReduce process here. So mapper basically does the filtration part, and the reducer does the aggregation on the mapper output. And if we look for AEA somewhere here, so the total volume for AEA was almost this. This was the total volume for AEA. If you count it, it's almost like 483 million, like 17, almost 483 millions. So this way you can process any type of data, and there are various mechanisms available, guys. So this was the webinar and a session on big data, understanding how we can store the data, and how does distributed storage and how does the distributed processing happens using a big data technology called Hadoop. Now, if you have any questions, you are open up. All of you can go and shoot your questions. A Spark is for Hadoop. Yeah, you can also divide. A file is a file, Ashish. Whether it's a video file or a text file, it does not make a difference. And Sunil, difference between Hadoop and Spark. Hadoop is an ecosystem. When you talk about Spark, Spark is a process engine. So you should be comparing, whenever you want to compare MapReduce and Spark. So currently what I've used MapReduce, and Spark is also a process engine. We can use other languages like Python, Ruby, Perl instead of Java also. And then you have to write one more piece of code, or you can call another class called sort comparable class. So you can use that and sort your data on the second column. And Spark RIPL normally helps you to process data in memory processing. So there is a lot of I/O happening whenever we process data using MapReduce. So in Spark, basically, we are avoiding that, and we are also able to create multiple chains of MapReduce. In fact, there are more jobs for fresher because they don't have any legacy to follow. So they are they can be easily understand about big data analytics. Abhishek, so there are a lot of opportunities for fresher and a lot of opportunities for, you can say, even for the experienced people. I don't think so Hadoop is going to become obsolete. In fact, Hadoop is going to be more in demand because now we need to process the data. Remember that even the current the government in India is going big in very big way after big data analytics. So you can't survive without any Hadoop ecosystem or Hadoop mechanism anymore. For PLSQL, you can use Hive very easily, Kiran. You can go for, since you are a PLSQL developer, so you know how to script a language or write a piece of code, you can easily go for Hive. On the contrary, Bhavna, for testers, there are a lot of opportunities because any tester would be a highly qualified data. You need to understand the flow of the code before you test the logic, right? So anybody who understands the flow or the coding part can easily enter into this field. Deepak, you can easily join in as a big data developer, so not to worry about. For jobs, you need to get in touch with the Collabora tech team. Since they have so many offices, they can easily find a good job for you. Hive is like for SQL guys, right? Ram Rajan, you can write SQL procedures in Hive. In fact, there are a lot of opportunities for both support guys, developer, and admin guys in Hadoop systems. And Arindam, you are from Oracle Application DB of 10 years of experience. Certainly, you can get a good opportunity in a Hadoop administration. So you can manage the Hadoop, the entire cluster. Because nowadays we talk about cluster size of more than 80,000 nodes, 100,000 nodes. So certainly, as a cluster grows, we need good admin guys also who can who can manage the cluster. Not compulsory that you should be having the Cloudera certification. If you go for Cloudera certification, all well and good, but need not to have the certification. Sardar, Indipal, the default block size is not even 64 anymore. It is 128. But we have an opportunity of configuring the block size. So I've configured my block size to 36 so that I can give you the hand-on experience how the blocks are being created. The growth of cluster is basically handling your cluster, how big your cluster is growing. So that is by adding more machines. MySQL can be used only for RDBMS, not in Hadoop ecosystem. And Umesh, you can get in touch with the support team for recording, and any help you need, you can get in touch with the support team. So guys, this is the web page. If you want any help, any support, you can get in touch on these numbers, and you can just pick up your phone and get in touch with the support team. They would really help you out. Deepak, certainly they have their offices across the globe, but do they have the office in Delhi? The support team would be in a better position to guide you. You can pick up the number and call them up immediately. And certainly they would help you out. They are into human manpower placement also, so they can also help you out in placing as per your skills and that you can get in touch. I'm a trainer, so I'm not into that level. Arindam, see, data analyst is not about writing the code, it is understanding the data. Since you are a DBA, you understand the data much better, so you are in a very good position to analyze the data. That depends upon the team. So I'm a full-time trainer, so it depends upon how and who is handling the job at that point of time, Ashish. So that's it, guys, for today. If you have any more questions, you can call up us or email us at jointac, or just pick up your phone or be in touch with us. We would be great to help you out. Hope all of you enjoyed the session today. And please, for your remaining questions, you can get in touch with us. And thank you, guys. Thank you very much for the session. Take care. Bye-bye.